Yes, sir. Yes, Imran, sir, we can start the session now.
Okay, thank you, Sachin. So, hello everyone. Good evening. I hope you all are doing very well. So, I'll just give you a recap of what we covered yesterday. Uh, we were discussing about the OSI layer model, right? So, in case you have any doubts related to that, to the previous session, please ask. Or else we'll continue from the network. So we finished transport layer and we'll be switching to the session layer for this session. So any questions related to any of the layers which we discussed yesterday, physical, data link, network, transport layer? I guess no. Yes, no, maybe. Right. This Macaulay Linux, I was trying to set it up for you guys just to show the demonstration, but the lab is still not complete. We are also setting up another lab for you guys where we can simulate the real-time cyber attack scenarios, the brute forcing or the spoofing attacks or credential harvesting, uh, the DDoS type of attacks will try to simulate in our upcoming sessions. So setting up the lab for you guys. Okay, so getting back.
Very much.
Okay. So actually, guys, we were discussing about this is the base of networks, right? And for a SOC analyst, it is good to have this idea because this is a must question when you are being interviewed for a SOC analyst role. And at the same time, one should be aware about the functionalities and the applications of each of the layers. So yesterday we covered the physical layer, data link layer, networks, and transport layer, where we covered the difference between TCP and UDP. We covered TCP handshake as well, and we covered how a DDoS actual attack happens, how adversary. Okay, so attacker is also known as adversary. So whenever you hear about a threat actor or attacker, adversary, so these names are same, belongs to that attacker who tries to compromise our organizations, who tries to compromise the confidentiality, integrity, or availability, or any one of them, to compromise the services which are there or get exfiltrates the data. Uh, so that's the name given to them, right? And maybe you would be hearing other names also, but these are the most common names which you'll hear in the when you'll join the security field. So I hope my screen is visible to everyone. Anyone?
Yes.
Yes, yes.
Yes, it is.
Right. So So I'll just finish up with all the layers. Now we are left with the session presentation and the application layer, and then we'll frame a story around that, like how it happens in real time, right? So if we say somebody is sitting in Delhi or in Chennai and wants to communicate to somebody who's sitting in the other side of the world, so how do they communicate following these layers? So that will cover this part, and in today's session we'll talk about the network, the attacks which happens on covering the networks, right? So DDoS, man in the middle attack, ARP poisoning, how does it happen, right? How what is SYN flooding, active scanning, right? So many people relate with these things, how DNS spoofing happens, right? So for the labs, sure, we'll be continuing with the labs when we'll be covering all these scenarios, how it happens from the attacker side, and how a defender team should be ready to protect it. And as a SOC analyst, if you see that alert on your screen, how would you start the investigation and when is the right time to escalate that offense to the next level? So that is all we'll be covering. So again, I'll just write it down. Anybody who can help me with the name which I have told, like I told you how we can remember all the 7 layers. So it was please do.
Physical, data, network, transport, session, app, presentation, application.
Absolutely right. So actually, I told yesterday for anybody who is not in working in the networks as of now, how they can remember this thing. It is with the line we can say, please do not throw sausage pizza away. Right? You can memorize this. This is a mnemonic. Uh, you can use this as a base, and you can just eventually, when you'll start reading about this and get into the depth of the things, these will be on your tips as you said. Right? So we have covered up till the transport layer, right, which maintains the reliability of the data. Right? We use two protocols, TCP and UDP, over the transport layer. Then what happens? The data moves to the another layer. That's a session layer. Session layer is very crucial, right? If you say managing the connections or communication between the hosts, providing it as a mechanism for authentication and ensuring that secure, reliable dialogue between the processes. So this is a bit of a complicated layer. If you would say it maintains the session between the two hosts. Let us break it down like this. So key protocols which works on this layer are, if we say PAP, right? Password authentication protocol, challenge handshake authentication protocol. So anything which is getting authenticated, right? So that works here. So anybody who knows which type of firewalls works on session layer, if you have heard. So let me tell you, firewalls works on session layer also. Anyone? Okay, can anybody tell like firewalls works on which layer?
It will work on
Layer
transport
3 and layer 7.
layer 4.
Layer 4.
Layer 3 and layer 7.
Okay.
Okay. So we have many answers, layer 3, layer 4, also layer 7. So let me tell you, the firewalls can work on layer 3, can work on session layer, can work, so which is layer 5. It works on application layer also. We have layer 7 firewalls, which are next generation firewalls, right? So I'm not sure like how many of you have seen like any firewall working on the session layer, but let me tell you, we call it as a circuit level gateway, or we call it as a circuit proxy firewall. Anybody who has heard about circuit proxy firewall? What is the functionality of circuit proxy firewall? So as its name suggests, it's a circuit proxy firewall, which works as a proxy only focused on the TCP sessions, right? It is not, it is like a gateway, right? It is not blocking anything. It just monitors and focuses on the TCP sessions by managing the connection, or you would say TCP handshake process, which initiates when we reached to the transport layer. So when the data reaches to the transport layer, it has to initiate a TCP connection, right? So here, when we have a firewall connected, it assists managing the connections for the handshake process, TCP handshake process. So since it acts as a proxy, it provides an anonymity and protect the internal network. So internal network, that's our priority. And we can place a NAT on this firewall, ensuring that our internal network is safe, right? So we NAT our internal devices and then we route the data to the destination. So that is what session layer does, right? So it's used for managing the connections and the communication between the hosts. So that, as simple as that. So I hope session layer is clear for you. It's a bit small layer as comparing to the 4 layers which are at the bottom. So if anybody asks the question, okay, my answer is it's a crucial for managing connections and between the hosts, right? So it set up the communication between source and the destination. Moving on to the presentation layer, which mainly focus on the formatting of the data. So I am sending out a data, right, from the application to the, okay, let's go upwards, and then we'll go to the real scenarios. Then I'll go from top to bottom, right? So it focus on the formatting, compression, and the encryption of the data. So if we want to, if we say the data encryption happens on which layer? Presentation layer. So it ensures the compatibility of exchange between the applications. So when we are sending the data from one application to the another applications, how the compression, decompression, encryption, decryption happening, that happens on the presentation layer. So, any doubt with this thing? Right. So when we move to
I have one doubt.
yeah, sure.
Yeah, Imran, I have one doubt.
Yeah, please ask.
In physical layer, data is in the form of bits. In data link
Right.
layer, it's in the form of frame, right?
Right.
And in network layer, data is in the form of
Packets,
packets. And transport layer,
segments.
okay. So in session layer,
So here the data is yeah, you are having the data. It is just trying to set it up the connection, maintaining the session from the source to the destination. So if we talk about the form of the data, that is primarily for layer 1 to 4. When you go to the session, it is for session controlling.
okay. Or in presentation layer, what is form of
So if
data?
we say you have a data which needs encoding, decoding, compression, decompression, encryption, decryption, that is what happens on the presentation layer,
Okay,
right? So SSL, TLS, you have these formats like JPEG or the other things that works on the presentation layer.
okay.
So when we go, yeah, you have any doubt?
No, no. Please, over to you.
Right. So when we go to the application layer, so here the real application works. So that's the interface which a user looks into. So if we talk about any of the application you are accessing, suppose WhatsApp, Facebook, so this is where you are. So you, if you are opening Outlook, if you are talking about the organization, so when you go into an interview, you talk about the things which are there in the organizations and are used on regular basis. So anybody who wants to send an email, what he'll do, he'll open an application which is Outlook, right? Belongs to Microsoft. So that's a user facing services, right? So when we talk about application, so many protocols works on application layer. If we say FTP file transfer protocol, we discussed yesterday. What is it? HTTPS, HTTP, SSH, Telnet, SMTP, and many more, right? So it provides a user interface for communication services and handles most applications through these protocols, I would say. But at the same time, this is the most vulnerable layer, right, for the cyber attacks, because this is where the user interacts. So user is not bothered about these layers, and even the attackers are not bothered if users are not. If anybody has to attack, so 90% attacks right now is starting from a phishing attack. So where do you see the phishing email on Outlook, right? So that's an application layer. So as I said, I'll repeat it again. It's a more vulnerable layer, and prevention measures which we can place are secure coding, patching, batch management. So if you are having an application server, it should be patched. We should enable input validation when we are hosting a web application server. So that's the control we should have as a preventive measures when we are talking about the cyber attacks, right? Any questions? So again, at the same time, most of you have answered that the firewall works on the network layer and the application layer. So we have next gen firewalls. Why we call it them the next gen firewalls? Because they have the visibility to the application layer. So if the data is getting encrypted and it is being sent through a firewall, which is having an app ID feature enabled. So what this firewall do is,
But that's like on Wi-Fi, by using Wi-Fi, which is done on which layer? Application layer itself.
sorry, if you are using what Wi-Fi. So if you are using
Public Wi-Fi.
Wi-Fi, so we discussed here, right? So you're using wired or wireless, working on data link layer. So here we are getting into collision detection and collision avoidance, right? That type of stuff. So if you're
So
using
this layer
Wi-Fi,
is
that
used
is,
in the,
sorry,
so
sorry, your voice is not clear.
I am saying that data link layer is also used in cyber attacks.
Still, your voice is breaking. We are not able to hear you properly. Saurabh.
Okay. Yes, now it is okay. Now I am audible. Hello.
Yes.
Now I am audible. Yes, I was saying that data link layer is used in cyber attacks, no?
Your voice is not clear.
Through Wi-Fi. It is still not clear.
No, actually,
Saurabh, you can, drop message in the chat box. Then we can read that.
so I think I've got your question. You want to ask like Wi-Fi works on which layer, right?
Right.
Okay. So if you were, so were you present sort of in the previous session yesterday, where we covered the wired and maybe I told the wireless also that works on the physical layer and the data link layer. So if we say, okay, I'll repeat it again. So Wi-Fi uses radio waves, right? Right. So it gives you a frequency. Maybe you would be using 2.5 gigs in your house. So that if you are configuring that, you'll do on the physical layer. But when you go to the data link layer, that's where the framing of the data is happening. And this is a concept related to in-depth networks. Now we are getting into that is collision detection and collision avoidance. So that's the difference between the wired which you used to use earlier as a LAN. So avoidance we have for the wireless, right? So there is no, I would say there is no collision when we are talking about the Wi-Fi's, right? Wireless networks.
Okay.
Right. So layers in layer one, you convert. So as it works on bits, it converts the bits into radio signals, right? And the data link layer, as we discussed, the data is in the form of frames, which handles the MAC addresses, right? And since we are using collision avoidance in wireless, so error checks are there. So that again, this is too much networking for any SOC analyst to learn. So if we start getting into the networks, it will be more of a CCNA course than the SOC one. So that's why we are not covering this, but we have a course for CCNA also. If you want to get into the depth of things, we can cover those in that discussions.
Okay.
Yeah. So I hope I have cleared your doubt for this wireless one, right?
Right.
Right. So again, let's start with a scenario. Okay, for the ones who are not working in the networks, that's very good. They would already be knowing how it happens. But I think we are just covering the basics. So we'll just switch to one scenario, how it happens for the OSI layer, and then we'll switch to the other components of networks like DHCP, DNS, and what happens on those devices, how attackers can use that for their benefit. So that we'll cover that as well. So any questions to these layers before I start the scenario? I guess no.
No, Imran.
Thanks, Shubham. Okay, let's take a scenario how actually it happens. Okay, so we have covered in depth how routing happens, switching happens, right? What is the role of a TCP, the transport layer, then what happens on session layer, presentation layer, application layer. So now let's take a scenario what happens. So suppose we say A is
Imran,
sitting in maybe,
I have one question. Can I ask?
yeah, sure.
Uh, O- OSI model and this TCP/IP model. So OSI model is documented, but TCP/IP is not documented still, right?
So we have not discussed it yet. We are just discussing the reference model as of now. The real application model is the same, but we cover 4 layers there. We'll come back to that. We have a PPT. We are not going into the depth of the PPT, but if you see here, I have this 6th slide ready. What all we cover. So if I would say here only, let's take this way. First 3 layers gets combined into the TCP, where you call it as a network layer. So right. So once again. Okay, then you have an internet layer, right? Then you have the transport layer, and then you have the application layer. This is how it is. So we combine these two as a network, then internet, transport, and then we combine these 3 as an application. So as a mnemonic, you can use it as NITA from the bottom, right? So we'll cover this. Let's cover the scenario first, and then we'll talk
Okay.
about it. Okay, getting back to the scenario. So suppose there is a user A, right? And he wants to talk to the user sitting here, we say B, right? So they are in different geographical locations. Suppose this is in maybe say Chennai, and this is you say New York, right? So now this person wants to talk to this guy and wants to send the message and say, okay, hi buddy, how are you? So what it does is it opens one of his application, maybe say, let's say Facebook. So opens an application, writes a hi message, hey, hi B, and what it sends is it starts sending. So where we at, this is what is this layer? Can anybody tell what is this layer? So it
This is application layer.
right. So A has just opened an application and he's just sending, he wants to send a text message to B and type in the message that that's an application layer, right? So writing a letter, so that's a user-friendly layer, that is what we discussed. So now he wants to send a message and he wants that message to be encrypted, right? So what happens is that's once this message leaves the application layer, reaches out to which layer? Presentation layer, right? So now he wants it to be encrypted. They are using some digital certificates here. They are just encrypting it. Not that this, they are using the encryption keys. For non-repudiation, we use the digital signatures. We'll cover that in cryptography, how it happens, why they are used. So once it sends out a message, it reaches to a presentation layer, it encrypts the data. Suppose the message is very heavy, it compresses it also, right? And then sends over to the session layer. So anybody you can tell what will be the role of session layer here? So session layer, anyone want to take a guess what will happen on session layer? Again, so session layer is just to initiate the connection, session, maintain the session, right? So it opens the session and sends the data to the next layer. So what is the next layer?
Transport layer.
अगला स्टेशन मोहन estate है.
Right. In transport layer, the data now starts getting broken, right? So data now breaks into the segments and numbers and the tagging is done on the transport layer if you are using the TCP, right? In UDP, it does not happen. It just sends out the data. It does not bother if it reaches to B or not. So it uses TCP, which is reliable. And then say you can say that TCP is one of that courier company which eventually gives you an acknowledgement when your packet is delivered to the destination. So that is why we call it TCP a reliable and UDP not reliable, right? So then it reaches to a network layer, right? So now network layer will decide, okay, where is B? Now network layer will see, okay, this is what has come to me and I want to route this message to B. Eventually what it will do is it will check the routes and will send the packet. So obviously the routers will be working here. We'll check the routing table. So where is B? Where is B? Okay, this is my route. I will send this data to the next layer I have. Can you give me 1 second, please, guys? Okay, sorry about that. So now it reaches to the data link layer, right? So now the traffic reaches to data link layer, where we have the switches. Now it reaches out, okay, this is B. Suppose B is using an IP, say 1.1.1.1, and here the data reaches out to your switch. Switch sees, okay, it is for 1.1.1.1. Do I have an entry in my ARP table? Right? Okay, it checks, okay, this 1.1.1.1, I have a MAC address for it. And at the same time, we'll check it and deliver it to Bob. where Bob's machine is connected, right, to that from that interface. So this is how the traffic gets delivered from A to B. Any questions in that? So anybody will ask the question, okay, you have not brought the physical layer here. Okay, so the link from this switch to Bob's machine, that's the physical layer. That's a physical medium from where the data is reaching to the Bob's machine. So I'll just say like this physical, these works on the bits. This data link layer, its work was to check the MAC address and sends the data to the Bob. Then see we say, and then we have this network layer. So network layer checks the routing and deliver it to the destination, and but just checking the route table. And then this transport layer, here the reliability of the connection establishes. It also combines the data, and then you have this session which accepts or initiates or maintain or finishes the session. Then you have the presentation where the encryption, decryption, compression, decompression happens, and then we have the application where it is user friendly, and then which is used actually to send out the data using the protocols which we discussed. So that is how it is. Any doubts in this? Or we'll just switch to the attacks which happens. Oh, actually we discussed DDoS yesterday. Anybody who can tell like what we discussed yesterday, how a DDoS happens or a DOS happen? So how many of you are working on firewalls? Are there any who are working on firewalls, routers? Guys, yes, no, maybe?
No, I'm not.
Okay, right. So we'll just, when we are talking about network security, right? So this particular attack follow phases similar to the network assessments which we do, right? It differs with the exploitation phases, but right, active can be passive. So active attacks can be passive, which is eavesdropping. Suppose like this person having one machine and this person having another machine wants to send out the data, and somebody who is sitting in the middle taps a wire on this thing and gets the data. Can it happen or not? Yes, of course, it can happen, right? So that is what we call that eavesdropping. Anybody know what is eavesdropping, passive eavesdropping? So where the sender and the receiver do not know that there is one other person who is sitting in the between and reading their conversation, or even can change it, spoof it, right? If A wants to send the data to B, it sends out the data, this person gets the data, changes the data and send it to B. And same, B replies to A thinking like A has sent the message, again sends out the data, it reaches to C, change the packet, change the data and send it again back to A. So that is how the eavesdropping happens, right? That is one attack scenario for if we talk about networks. The other ones we discussed yesterday, DOS attacks, how it happens. Anybody who was there in the yesterday session can tell me like how DOS attack happens, or I'll explain it again just with a brief example.
Denial of
So
service.
Yeah,
yeah, flooding the servers with multiple requests, and yeah,
absolutely.
usually that happens with that sync.
A malicious cyber attack embed making computer network resource unavailable.
Absolutely, it affects the availability part. If we talk about the CIA triad, right? That's the motive of the attacker here is. He wants to choke the bandwidth of this web server and does not want it to be available for the authorized users. But how do they do it?
Okay, they
By
send
flooding the
the
target
sync.
traffic.
Right? By flooding the target? How? That's the
They
question you'll
send
get.
the sync,
Consuming the
and they will get
uh,
the.
processing power.
Right? Somebody answered consuming the bandwidth. Absolutely right. But how? Again, the question gets how.
Okay, they will try to have a sync into the server by giving the sync request, and they will get the sync acknowledgement, but they will not give the acknowledgement back, and it will be
Absolutely
still
right.
open. So
Absolutely right.
Malform packets. They can send malform packets, right?
Right. They can send a malformed package, but what they do here is they actually uses the legitimate TCP handshake and abuses that, right, to eventually choke the bandwidth, or you can say the resources of this web application server, so that it is left with no resources to actually respond to the authenticated users or authorized users who are coming legitimately and want to try the services which are hosted on this web app, right? What they do is they have a bot army, right? So they configure a bot army. They use tools like Nmap. So that is what I was trying to set up here. So Kali Linux, maybe they would be using the same, right? So what they do is one of you have already answered, so they send out the TCP SYN packet, and respond to that they get a TCP SYNAC. And what they do is they don't send the acknowledgement packet. So what happens, this web server thinks, okay, this source will come back to me again, but it does not happen. It reserves some resource for this bot. Again, this thing happened from here also, this thing happened from here also. So eventually it consumes all the bandwidth of this server and make it unavailable for the legitimate users. This is how it is. But at the same time, this is one of the TCP abuse, TCP handshake abuse which they are using. But what about UDP? Can they use UDP also? Anyone? Yes, they
will
can.
they be able to, yeah, will they be able to send, multiple bot requests for particular services on that through this
Absolutely.
UTP, and they will flood it? Yeah.
Yes, absolutely. They can do it. Yes. Nobody is stopping you. You have a destination IP, you have an map tool. You want to send as many as packets through that particular IP, you can send it, right? But at the same time, what protection they have on this side, that's WAF, right? And in the WAF, you configure the rate limit rules, right? That is what we're going to cover. So right now I'm just talking about the how attack happens, then we'll go how we can defend it. That's the part of a SOC analyst, recommending the clients how they can protect their environments from the web application attacks. So during this course we'll be covering the WASP top 10 vulnerabilities which are in the wild being exploited by the threat actors, again adversaries we can say. So how WAF can be configured with the rule set, so to I would say to prevent those attacks, right? That is all we'll be covering. So getting back to this thing, if we say TCP handshake was used to abuse, they can also use UDP. That is what we call as Fragile attack, right? This bot can send the UDP packets, right, instead of TCP, and then again this can happen. This will also send, and it eventually chokes it. So that's a Fragile attack we call it. And same time, if they use this ICMP, right? So we say ICMP echo, and so this server will reply to the with the echo replies. That's also trying to overwhelm this device executing the DDoS. So that is what is known as the Smurf attack, right? Anybody Fragile attack that uses the UDP for DDoS. Smurf. So guys, you have to remember this. What is a Smurf attack? It uses ICMP to perform DDoS. The attacker uses ICMP. Any questions with respect to this one?
What is ICMP?
Internet Control Message Protocol. So have you heard about ping? So if you have to check, okay, if Google DNS is working fine or not, have you ever tried how a ping works? I'll just give you a real-time
Yes.
example. You open a command prompt. Yes, anybody who's working in networks would be doing this day in, day out just to check their devices are up or not.
We
Somebody
check
who's
the
not.
source packets IP. By pinging IP, we can check the source
Right.
destination
Let me
packets.
Google DNS and you see that it's pinging, right? So that means it is sending the echo and getting the echo replies in response to that. Right, that is what ICMP is. So these bots sends a ping packet, ping traffic here. So what eventually does is a web server says, okay, yes, I am alive, and respond to those packets, right? And it gets busy, it gets its resources busy replying to these bots, telling them, okay, yes, I'm alive, as I did for 8.8.8.8 here. That's a Google DNS. Its resources get uh, consumed, and it won't be able to reply to the legitimate users. Again, the main aim is to choke the bandwidth, the resources of this server. So sometimes you don't get a destination, so it just check if the destination is alive. Here the bots are checking the destination is alive. Again, they get a TTL also. We configure TTL specifically time. This is time to live, right? And it sets out like if it reaches to that level, that TTL, it should be drawn out, right? It should not go beyond that, right? So that is what we say, if destination is reachable or destination is not reachable. I think I'm making sense here, guys, right?
Right.
So let us talk about layer 2 attacks. Anyone knows about what happens on data link layer, how attacker can use this layer to perform a cyber attack? Anyone? Suppose this switch. Anybody has heard
Yes,
about ARP?
sir. Yes, sir. Access resolution protocol.
Right.
The Wi-Fi attacks are done through the ARP breaking by the intrusion of this cache memory. In cache memory, they break the ARP resolution. So the Wi-Fi cyber attacks are done by through that public Wi-Fi. When there is
That's
some
ARP
ARP, they
poisoning.
break the ARP.
Yeah, it is
Right.
ARP poisoning.
Right. So what attacker does is it exploits the ARP, right? So as you said, it is address resolution protocol. So why we are discussing this? Because since we are discussing networks and we are discussing what attacks can happen on which layer, like we discussed sniffing, we discussed man in the middle, like the network. Now we are discussing for the data link layer. So ARP, that is what it is. Attacker exploits ARP by sending malicious ARP replies, right? It's not like it goes and changes the entry in the ARP, that ARP spoofing, right? It is trying ARP poisoning. Attacker exploits it by sending malicious ARP replies, right? So this trick the switch. So suppose this is switch. So here the attacker, what it does is gets, so once it has the ARP table, right? So two type of attacks. People get confused in what is ARP poisoning and what is ARP spoofing.
Right.
Anybody who wants to answer, just a brief of it, then I'll start explaining. Anyone?
It is a type of cyber attack that is falsified ARP message to link their MAC address. Like they may share some QR code to scan, to send some falsified ARP message to link the MAC address. When they get the MAC address, they can easily attack.
Okay, right. So that's how it will be difficult for so somebody who's working having good like knowledge of the networks can understand this. But if we talk about a real-time example, the spoofing, whenever you heard this spoofing, even IP spoofing, MAC spoofing, ARP spoofing, there you know that this person is lying to you.
Right. Falsified, right? Right.
Right? It's falsified. And when you see a poison, so when you give a poison to anybody, he dies, right?
Right. Right.
So And if you talk about, if somebody goes and tell the poison things about the others, then the other person believe in lie. So it is lying. This is believing in lying.
Right. Right. Right.
Right. So in real terms, if I would say, so just like MITM, if I would say, it happens, it can happen. So what it does is, so ARP spoofing is the act of sending fake, right? It is lying. It is fake, sending fake ARP messages to the network. It wants switch to know that, okay, no, I am that MAC address, not that actual user. So that is how they come and changes the MAC address of their machine, right? And when
They mask. You are using masking of that in the spoofing. They use masking, right? Masking of that MAC address.
So if we specifically about masking and tokenization, so that is what, like, if I'll start explaining in that way, but when we'll switch to those modules, you'll get confused. So that's why I'm not telling about masking, but yes, you are right. It is the masking, but
Okay.
but we can say that it is sending a fake ARP messages. How about this? Right? ARP spoofing is lying about the MAC. Let's say it this way. Right? Okay, no, okay, somebody who is actual user having that same MAC address, suppose aa.bb.cc.ed, let's write it down. This person comes and he knows that, okay, this is the MAC address here. I will just change my MAC address. Okay, for your information, it can be changed. Many people think it cannot be changed. It can be. This person comes and sign the same MAC address. Now the ARP entry goes here, connected to this switch, updates it against the IP which this guy is having, right? Removes the entry or updates the entry from this IP to this IP. Now switch knows, okay, this MAC address, let me send out up, just taking the up table to this guy. That's ARP spoofing for you. Right? So, but in ARP poisoning, you change the entries directly into the ARP table, making it believe that the new entries are the valid ones, and that this actually leads to the traffic redirection, right? Right. Any doubt with this thing? Because we'll be covering this again when we'll be talking about completely about cyber attacks. So how it happens.
Sir, can you explain with some practical scenario this spoofing and poisoning? Examples with
It does.
examples. How?
Yeah,
Yeah.
actually, I was asking about that because recently, I mean, few years back, there was a attack that whenever we are, going to Google and we are trying to enter into a website, there are multiple fake websites where we were all, I mean, redirected to the fake websites. This is regarding that, right?
So that's also spoofing, domain spoofing, right? We'll cover
Yeah,
that
domain.
also. So again,
Okay.
I'll say, if we talk about spoofing, then you are talking about lies. That was a fake domain, right? Or a domain which is trying to be the legitimate one, but it is not. So that is how
Hmm.
we have email spoofing, IP spoofing, right? It shows you that it's a genuine, but it is not. It could be attacker's domain, it could be attacker's IP. Again, it could be attacker's MAC address when we're talking about ARP spoofing, right?
Okay. Any example of this attack?
Yeah, sure. So suppose, okay, let's cover one slide before that. So I'll cover to that question also a real example for house spoofing and poisoning, maybe in upcoming sessions, not an issue.
So this Trojans, this virus and Trojans are like poison. Poison. It is like a poison one, or
So
spoofing. It comes under spoofing.
so you calling, no, it's a malware. Both are malwares. So that's a different all story. So virus who is
Okay.
having a malicious code, right? It can be injected having a file through a file, say macros or all. That's a
Right,
virus
right.
for you. But if you talk about Trojans, it looks like, yes, the spoofing. It looks like a legitimate one, but it is not. So you go in a website and things like, okay, this is the game I want to download, but you don't know what is the code of that particular game, right? So you download it thinking like, okay, I'm installing some game, but that's actually not a game. That's a Trojan, right? That's a Trojan for you. That's a malicious code. That's a malware.
Okay.
All right. So one of you has asked this question, how domain spoofing happens, right? So before that, let's see what is DNS, right? So DNS, it is for us, right? We cannot remember the IPs all the time. We need the the wordings, we need the lines, right, or the alphabets to understand, right? You cannot remember 93.184, or you cannot remember always, okay, 8.8.8.8 is the Google DNS, but eventually you have to, because it is most probably used. But again, for all the websites, you cannot remember their uh, IP addresses. Suppose if we say, if I have to do NS lookup for any of the websites, we say zoom.com. So you have this Zoom IP, but you cannot remember this. Who is doing this for us? That is the DNS who is converting this domain to this IP for us, right? So whenever you open a Google and type in google.com, it goes to the DNS, checks for the IP, brings that IP for your machine because your machine understands the IP, right? And then converts it to the binary and then sends the data out. And that is how it is. So if we talk about DNS, how does a translation happens, right? DNS query when sends domain is requested, or then the DNS server responds back to the IP address, right? So what happens actually, I'll just cover that part. So suppose this person sitting here wants to access example.com. What happens? It first search into the DNS cache, which calls that recursive resolver as well, DNS resolver as well, right? So it checks for the DNS from the DNS cache. Okay, I have it. Do I have the IP for it? It says, no, I don't have the IP. So what it does is it goes to the root domain. That is this dot. Okay, what is there in there? That's a dot. So it goes to the root server and brings out, okay, I have this dot, I have it with me. Then it searches for what else. I want my top level domain is com. Okay, so then you go here. It goes to the fourth step, get the result. Okay, .com. I have the list of .com domains with me. You have it. So and then it checks, okay, I have example.com. Then again this DNS resolver send it to directly to example.com. That is the name server, gets the IP for that, then resolves this query for this user, and then directly access that server. So I think it would be more complicated for the one who has not seen the DNS how it works, but I'll just repeat it again. This is a hierarchy which it follows. Okay, so this is as simple as that. So anyone who's placing out a email, the domain name, suppose we say facebook.com. So if your DNS is not able to resolve that to an IP because it is not in that cache, but once it gets the result, it stores in the cache. You don't have to follow this process again and again. So first it checks in the cache. So it's a cache. So it checks for, once it is not there, it checks for the root server, which is a dot, right? It says, okay, that's .com. If you want, you go to this TLD domain, TLD server, top level domain server. Okay, this top level domain server says, okay, I have these many domains associated with me. What are you looking for? I'm looking for facebook.com. It goes to facebook.com, gets, this is the name server or the authoritative name server, gets that IP, resolves it for this person. Now this person has an IP, this machine, and now this machine can reach out to that server directly, right? This is how it is. But getting back to that question, how a DNS spoofing happens. So
DNS
suppose,
session is part of what?
sorry,
Imran, I wanted to know. DNS cache, you just mentioned that DNS cache. DNS cache is the part of server, it's a part of domain server, yeah, it's a part of You know,
No. So it resides on that particular application itself. I would say like this.
where
Then
query has been generated, right?
on the PC, yes, the machine which
Oh,
is looking into. So
okay.
once I get the results back to my machine, it stores into that cache. It does not have to go to DNS server again and again to get the IP. It stores in that
Okay.
IP server. Right?
Okay. It means DNS cache is the part of browser, right?
So that is what our part of our machine, which from where we are operating. Yes, the local machine, the browsers.
Okay.
So these browsers have these internal DNA cache, right? But when they don't get an IP which they are looking for, then it goes to the DNS recursive resolver. DNS resolver, we'd say. Then it goes to recursive resolver, right? As I explained into that diagram. So for a SOC analyst, it is very important to understand how a DNS work, how a DNS performs, what is the functionality, how does it function, right? So this is how it is function. But if you get into depth of that, please, we'll discuss this more in detail. But if we talk specifically about the cyber attacks, how it happens, right? Give me 1 second, please. Sorry. So suppose this person sitting in the office, say A, and he wants to access, say, google.com. So that was the granular details which we covered. Now we'll cover the overview, right? I have a tendency when we go into depth and then cover the actual application, which you will tell in the real interviews. If you are being interviewed for SOC L1, L2s. So they won't be asking you this question if you are being interviewed for L3 for sure. So, and they are just expecting that you know it already. That is why. So if this A person has to access google.com and have this DNS inside its organization, so what happens is this guy goes, types in the application, maybe in Google Chrome, google.com, or maybe in the Edge, google.com. What it does is first thing, it checks into its cache. Right? I have this the IP against this URL. No, maybe no. So now what it does is I have a DNS configured on my machine. So my DNS is my internal DNS. Say they are using the DNS IP internal IP 10.1.1.2. So it reaches out to the DNS. Okay, DNS, do you have the IP for google.com? Suppose it has the IP. It reverts back. Suppose it does not have the IP, then what? Anyone?
It will go to the next, the internet to find it.
Right. It won't go and search the complete internet. So this DNS server would be replicating all the records from the another DNS, say Google DNS, maybe, or maybe not, or maybe the ISP's DNS, which is connecting to the Google DNS. Right. So this DNS will go and ask the ISP's DNS, okay, do you have it for me? So it says, okay, yes, I have it. Most of the results would be getting from the external DNS, which could be the ISPs or Google, as I said. So once it gets the IP, updates its records, sends the IP back to the system. Now this system has got an IP, then it can access google.com via the defined route, either by the proxy or the firewall they have configured in their organization. That is how it is. Suppose you go for google.com and your DNS server is already compromised. Let's say this way. And the attacker has changed the record here. Right? He says like google.com. Okay, if you want to google.com, suppose this is the attacker server. It has an IP of say 196.1.2.10. So what it does is it updates the records again google.com for his IP. So now he gets the IP. It will be routed not to the actual Google server. It will be routed to this attacker's machine. So we have DNS sync holing configured on our layer 7 firewall, NextGen firewalls, to protect this type of scenarios. Any questions? I guess no. Getting back, so we'll cover again. I'll say we'll cover these cyber attacks in detail with simulations, how this happens, what they do, using Kali Linux and setting up our own DNS servers. It would be feasible. If not, we'll be using the Google DNS server. Right. But if we have to change anything, we cannot go and change it on the Google DNS servers. So please don't be mistaken. But it is why do if we have a Google DNS server, why do we need internal server? So that's a question. Anybody wants to answer this question? I guess if we have, like, suppose, who would mind having a free DNS services? Why would they configure internally? Because you cannot trust something which is there on the internet, right? So suppose I am the attacker, right? I configure my server. I want to host this server for, say, a streaming website, right? I host the server. What I do is I host it over the internet, right? Somebody who is sitting in the internal network, or we say intranet, having a firewall here, right? He's sitting here. So this person gets to know about my website, say imran.com. So this person came to know, okay, this is a wonderful website. I can go and search. I'm getting bored in the office. So what did it executes imran.com. It reaches out to the internal DNS server. It says, okay, I don't have this. So if we don't have the internal DNS, so let's say this way. So this person will directly go to the Google DNS, which is also on the cloud. And suppose it is going via firewall, it will go route through the firewall to this DNS. So I'll not be having any issues setting up this record in Google DNS for sure, because Google does not know. It will just host the domains, right? It gets it from the IPs. I'll just contact one of the IP. I want to host my domain. It will just get synced to the external domains, the worldwide. Now this user go and checks up. Okay, I want to access imran.com, gets an IP for it, and starts accessing my website, right? Now it does not know it is connected to my server. Now as an attacker, I can communicate to this guy, right? He can send out a post messages, although not the get, but there are many ways. I can just place a malware here. He just click on a link, get that malware downloaded on his machine, and boom. From there, we'll start changing the registries, exfiltrations, maintaining the backdoors, persistence. So many things can happen after that. That that so these are the real scenarios how it happens. So that is why we need DNS tunneling, right? So why DNS tunneling? So attackers are getting smart as the tools are getting smart. So what they do is they start exploiting, just like TCP handshake they did for the DDoS. Now they are abusing this query and response feature of DNS, right? So this person queries, right, and get a response. So for that, they are placing a rogue DNS servers. That's another sort of story which we'll be covering. So any questions with this? I guess no. Yes, no, maybe. So guys, if you'll ask the questions, the more understanding you'll get. I guess no.
Sir, this
Sorry,
DNS.
sorry, your
Sir,
voice is not clear.
this the okay. Wait a minute. Hello, I'm audible. Now it is audible.
Yes.
I
Yes,
was
you are.
asking that in this DNS system, the attacker they get inside the firewall, or they leaving the firewall.
No. So the user which is sitting inside the network. So this is intranet, right? So that's an internal network. For the outbound connection, you have placed a firewall policy here, which says if my users comes and wants to access any website on 443, right? You don't restrict, actually you don't restrict the websites or the web traffic. You allow it from source to destination. So once it starts getting the encrypted traffic, right? So firewall, which is not using the app ID feature, won't be knowing that what is going inside that packet, or even if it is going, it would be fine. But when the return traffic comes back with the malware, if you have an app ID feature enabled in this firewall, which we have in Palo Alto, it will decrypt the packet, see, okay, there is a malware going on, drop this connection. So that's it. That is how you can prevent it. But this is how attack happens. So now mostly the web traffic is going through the proxy, right? There you also have the SSL inspection in place. The same thing happens, but still attackers are smart. They are just manipulating with the payloads of this malware, the coding of this malware, or I would say the payload itself. They just trick it in a way that the inspectors are not able to detect them, and eventually drops this malware into this machine and starts compromising, performing the later movements and all.
Okay. Okay.
All right. Any more questions? I think we are over time. So Sachin, I think we are good with this session as of now. We have covered most of the part from security. Few of the slides are left. If I would say the DSCP, I think most of them already know the networks, but we can still cover the subnetting part, how Active Directory flows, what is the usage, and how it can be exploited. Again, the SMTP, how it can be abused by the attackers. The protocols we have already covered. So I think we are good with the network part. Only one session will be remaining for networks, and then we'll be switching to core security, the modules.
Definitely, sir. Definitely. We can end up the session for today, and we can connect by tomorrow. And who have not taken enrollment, you can connect with the admission team, please. Yeah. Okay, sir. Good night. Good night, everyone. Thank you for the time today.
Thank you, everyone. Have a good night. Bye.
Well explained. Thank you.